kind of introduction. On my day-to-day I work on the tidymodels team, making models easy to feed and run and analyze. And I won't be talking about that at all today. I'll be talking about the wonderful purrr package, which is being developed by the adjacent tidymodels team. If you're interested in following the slides, you can go to this link, and you can see what I'm seeing as well. It's fairly simple. You can also find it, go to GitHub/Emil Hvitfeldt, and it's the most recent repository I put up. So we'll be talking about the purrr package. It is one of the core tidymodels tidybest packages. It's been around for a long time. And if you go to the pages themselves, it will say that purrr enhances R's functional programming toolkit by providing a completely consistent set of tools for working with functions and vectors. And there's a couple of core parts about this. The first part is that it talks about the functional programming toolkit we're working with. So that, for this purpose, means that we are having objects and we are passing them into functions. So functions is a first class object in R. So we have an object and we can pass it into a function and something just comes out, as opposed to having objects with functions attached. And so just nice and easy way of applying functions to whatever we're working with. So then we're with functions, and more importantly, we're working with vectors. So vectors is also a very fundamental part of what we're working with in R. And for this purpose, in purrr, we're really talking about any object that has a number of elements. So it can be a vector of length n, or it can be a list, or it can be a data frame, which is a list. It can be anything that you can say the first element of, the second element of, and so on and so forth. It is a highly used package, a fairly light package with no dependencies. It has a total of 1,490 reverse dependencies across train as of 4 p.m. today. It is used all over, and I use it more or less every day in the packages that we maintain. And the reason why I'm talking here, as we said, is that there was the main major release that happened in very end of last year, where they wrapped up the last finance, and it's more or less in a stable state right now. We aren't expecting any major revisions to happen, and we're very happy about that. So I'll be talking about starting at the foundation, building up a little bit, seeing what we have to offer, sprinkling in a couple of the new things that we are seeing in this package. It doesn't actually, while it is a 1.0 version, it doesn't have a lot of new things, because it was already a fairly stable package, but we did see some new things. Okay. So for some of these examples, I will be using this data set I made of letter sets, and when they were published, when they were available, and what parts were included in it. And I made it this really nice JSON file, where if we look at the first element, there's this really long list that's nested with all the different parts, and the names, and the colors, and the IDs, and everything. And in and of itself, nested lists are a pain to work with, because even the print is hard. And we're going to see if we can use purrr to help us working with these types of files. Before we move on, I'm using some slightly new notation. So as of our version 4.10, we have a native pipe. So if you're familiar with the Madrida pipe, it can do most of the same things. It is a syntax transformer, meaning that it doesn't add runtime. When you run this code and evaluates it in R, what ends up being evaluated is the transformed version. So it doesn't add any overhead to your calculations, so it's always fast. It does mean that it isn't a one-to-one. So there's a couple of things you can't do, but it's more or less a replacement. And if you're not familiar with it, the pipe means that instead of saying f of x, we can then say f pipe into x. And this becomes really nice once we start doing that long deploy chain, like applying multiple functions to the output. It's just another way of doing it. We also have, in the same version, a new shorthand for creating functions. So normally you say function, parenthesis x, and then whatever code to do something. We can now, in version 4.1.0 or later, you can do a dash instead of the function keyword. And it will produce the same thing. It's just a shorthand of working with it. And we'll see later why that is sometimes helpful to do. If you're familiar with other programming languages, the slash is the closest symbol we could use for like a lambda expression. So that's like how to maybe offhand think of it. And we'll be using this instead of the normally supported per function interface, which was the tilde.x. Mainly because that only worked in some functions where this other shorthand will work anywhere. It doesn't have to be just in per. So, the main thing that Purrr really has to offer you is working with maps. And what a map function is a function that transforms some input by applying the same function to each element, creating a new object of the same length as the original one. So the main thing about this is that we're applying some function to each element. So you have n things coming in, and you have n things coming out, and the same function was applied to each element. And another important thing is you have the same length coming back out on the other side. And I think on a syntax level, what we really have is we first have a vector as the first argument and some function that we want to apply to it. And with small examples, we should imagine we have map on the vector 1 through 4. We apply r unif, which creates a random uniform number between 0 and 1. So first, this is 1 random number, then 2, then 3, then 4. Since data frames are technically lists with the added constraint that they have to be the same length, we can also map over a data frame because we just map over a list underneath. So if we want to map over an empty task data set and apply the mean, what it realizes into is calculating the mean of each column. So that's the general syntax about how we use these map functions. And we do like a couple of other things. If we didn't have a built-in function, we just write our own function. We can say, I want the second lowest value. We create the function, and we pass it in, and it gives us the second lowest value of each element. Is that a question?
Yeah, but am I allowed to ask questions in the middle?
Any questions is welcome.
So what is it about map that makes it like default to the columns and instead, I mean, I know that of course is what makes sense, but like how do you know that it's not going across the rows to calculate the mean or whatever?
But this is a question. It's because a data frame, so a data frame is a collection of vectors.
Yes.
So it's like a, I want to say column
the first item is the first column.
Yeah.
Got it. Okay, I understand.
And of course, you don't always think of that in your day-to-day as a data frame as being a list of columns.
Yeah.
But that is how it's being treated in R, so that's how you iterate over.
Got it. Thank you.
You're welcome. But why? So we created a function before, and we pass it in, but we can also create our function inline. So, because if I just want to care about getting the set and load value once, it's sometimes a little tedious having to create all these functions that's only used once. So we could just create our function inline using this function shorthand. So we're seeing that the total right here sort of adds and set an element, and sort of adds set an element is the same, but we just created it inline as an anonymous function, so it just materializes when we call it, and then it goes into the ether afterwards. So we can just map away without having to deal with these extra elements, extra functions. And I lied earlier by saying we had 2 arguments. We technically have another one, because we can also pass in arguments. So before, when I did apply the mean to each element, we can also pass in any argument to the function that we passed in. So here we are mapping over empty class, calculate the mean, but we're also saying to mean, remove all the missing values, which this is essentially the same as with these 2 sides are saying the same thing. But the left-hand side, in my eyes, are more elegant. You don't have to create a function to pass arguments, it just knows to pass it through. So if you've been using R in your programming language, this might feel familiar, and it is. So map is almost identical. Well, so if you don't use any of the new fancy perf features, map and lapply will do the same thing. They both take in something and pass out a list. But it's also very similar to using a for loop. So here, on the left-hand side, we have a per example, we're mapping over vector x, applying function f. And we're getting the value sort as a list. And we can generate the same code as a for loop on the right-hand side. And I think this example partly illustrates why sometimes purrr is the nicer solution, or just the functional approach of mapping over, because we don't have to do all this housekeeping to make sure we're iterating over the same elements. And also a little pop quiz here, which might be a little hard, I don't know. Can anyone tell me what the difference is between those 2 statements? So what happened? So if you run those 2 pieces of code, it will do something different. Anyone tell me what the different thing is?
Prizes for pop quizzes.
It's subtle little, oh, yeah.
Is it just that you create this I variable?
Yes. Well done. So after this is run, you will have an I variable that is has the same value as the length of x coming in here. And in most cases, it doesn't really matter. But it could matter if you accidentally used I for something else. So you need to make sure, not only are you using a for loop, but you need to make sure the iterator is unique and not used somewhere else, where you don't have to think about that using the map. And also you have to, if you do it right, you need to pre-allocate everything up front, which purrr will just do for you. And so everything so far, we saw map used returning lists of the same length, but we have a bunch of different variants for the most common use cases. So if you know the output will always be a singular, like a scalar, a character variable, you can just use map underscore chr, and it will take the resulting list and turn it into a character vector. And here's one of the first new things. And so we have like logical, integer, double, which is numeric, character, and this new one, which is vector. So that will do what the other ones do, but for any other common type. So it will do factors, it can do like SFR pairs, it can do date times. So it's just a catch-all function for any variable type you could imagine. So it can either, when you use it, you can either have it automatically find the common one, or you can specify like the prototype, saying, I want all of these objects to come out as factors, and then it will make sure it happens, or error, if not. And last, at the bottom, we have the walk function, which will return side effects, meaning things that doesn't change anything in the environment. So it could be writing to a file, or send a message here, like print stuff to the screen. I'll have examples why that is sometimes useful. So we already have a level data set, and we can, like, let's say we want to find the names of all the sets. We write this little shorthand function to say, inside each element, that the first element of the name. And everything pops up. And I don't know why some of the names are different. They're different IDs, they're just the same names. We can also, like, let's say we want to find in all different parts. So the way I actually, in my day-to-day, when I set up my first map, is I subset in to my first element in the list, done working on, and here I'm seeing, so we want to find a number of parts, and we ignore that it already has it. We don't do it the hard way. Yeah. So we go in and see, oh, there's an element of parts that's like really big and annoying. So I start by then jumping into the parts. And we see, and we slowly find out, oh, I need to subset into it. So this is inside another list. We go in here, and then we find the length of that. So now we know how to do it with the first element. So then we take everything right here, that's going to be the body of a new function, and we replace this first element with set. And we just create this function right here. That's the new inner function we're doing, and we can apply it to everything. And it will just wait where we expected. And since we're counting the number of elements, we'll know it's going to be an integer. So we set the more specific map int to specify we want integers back. When at all possible, I try to use integer as a type, because I will get warnings if I did something wrong and I did better half. Question?
Okay, so a lot of times when you want to work with variables, with column names as variables, you have to do like closure. I don't even know what these words mean. Yeah. But it looks like you've made your argument the name of the object, and it doesn't have any problem with that.
So this is not, yeah, so this is, so right here, is a little hard to see. This is basically a function right here. That is like a function of the variable set. Yeah. And then once inside the function, we take whatever's been passed into it, it takes the parts object of that, first one, then take the length. You only need, and that is valid, I know what to do with that. You need closures and things like that if you use any non-standard evaluations, so like anything dplyr or some other things. Right. But here is that we just saying the name, we're just saying, give me the parts one. And this just matches like directly name-wise.
But the set is the part that has to match from the argument.
Yeah, so set needs to match over here.
Yeah.
So normally, when you're lazy, you just use X as like the thing. But I also want to show you can do set as a function name.
But in the previous examples, oh, okay, never mind. It's not the name of the function. Okay.
No,
okay.
But it's an anonymous function with one argument called set.
Okay, thank you. I'll try to swap that up.
So then.
And there you go, that's right, okay.
Yeah, that's the other one. We can all, so right now we created vectors, but we can also spend a little bit more time and just create data frames right away. So here we're doing a little bit more like advanced things, but we'll go through it step by step. So if we start down here, I'm mapping over the set. applying this extract info function to each Lego set we have. So let's see what this extract info does. It creates a data frame, and I'm extracting out the year, I'm extracting out the name, and then I'm doing, because we had a list within a list, I'm actually just putting another little map in here to get back all the colors and then pull out the most common. That will come out as a list of one-row data frames, which we will then combine with this list R-bind. So it's a row bind of lists. And if the data frames are the same, we just create a data frame. This is very similar to what people used to see as map underscore DFR. So we are now thinking that map DFR was a little confusing because it didn't return the same length. It did technically mapping and then R-binding. So we now have a way of doing that separately. So map DFR, map DFC is superseded in the sense that bus will be fetched, but we don't think it's no longer the best way of doing it. But yeah, so we can use purrr to create data frames as long as the data frames created in each iteration produces the same thing. We can R-bind data frames better. We also, so we see the map functions, we also have these other ones called map2. So instead of one vector coming in, we have two, and we apply a function. So we could, here we're passing in two, just list of numbers, and we're creating another function right here that basically says the first number needs to be the number of random normal variables generated, and the second number should specify the standard deviation. And we can do that. So sometimes you want to have a function that is applied to two things, and we can do that. We can also, that's the generalized version where we pass in a list of things. And it can be any list as long as the function at the end knows to handle all these different objects. So here we're passing in three lists of the same length, and then sum is applied to the first element of X, Y, and Z, then it's applied to the second element of X, Y, and Z, and lastly it's applied to the third element of X, Y, and Z. So that's the last generalization. And map2 and pmap also have the underscore variant. So you can also say different vector numerary, different vector character. So it's just depending on the number of inputs. What's new now? Just 2 seconds for that. It should repeat. Okay. So one of the new things in version 1 is we now have progress bars. So if you do a thing that takes a little while in a map function, you can now specify .progress equals true, and you get a neat little progress bar telling you how far you are and roughly how long it will take. And you can also pass in a custom progress bar if you don't like this one. But it's a very nice quality of life improvement, especially if what you're taking takes a while. Yeah. So as you can see, I had to make it sleep for like a little bit to even have it show up as numbers. But I have a figure it takes 10 minutes each morning, and it's nice to just know like how far I am from being able to close my computer. Another thing that's also included in the new 1.0 release is better error messages if something didn't work correctly. So if you did an error, it will now say at what element you have the error in. So if you iterated over 100,000 observations and it just broke, it now says, I saw the error in observation 1204. So you can just manually figure out where it is instead of having to bisect your way to the right value. So that just comes in, it just don't do anything, it just happens automatically. Another set of functions which is kind of nice, and you sometimes need it, is the idea of plotting. There's a new, there's a function, not new function in Purrr called plot, and it's just a different way of subsetting in. So here we have the Lego set, and we can say plot 3 means the third element, and then inside that, I pull out the element named parts. And it's just a different way of saying this. You just specify that, but sometimes it's really nice to just be able to say you have a variable and you know that you need to, it's like deeply nested, but you know the names, you just pass it in as this. I use this sometimes, it's kind of nice. It also includes a set of function modifiers. So this is functions, you apply to functions. But they're really useful in like certain applications. So if you have a function that sometimes errors, or then you might want to wrap it in possibly, and I'll show next slide how to do it. But if you take a function and modify it using possibly, you can say what the value should be if it errored. So if you wanted to take a logarithm of a negative number, I think. Can you do that? That does have error. Some mathematical operations error if you try to do it.
Yes, R throws you a NAND, so it doesn't error at warning messages.
But some things will error. You can possibly you can specify what the error message, what the value should be instead of an error. With quietly, it removes all the things that are printed, which is sometimes really nice, especially if it like prints a lot. You just quietly wrap it. It silences everything, but also captures it. So you can still like retrieve it later, but it doesn't clutter up all the logging if you have it. Safely captures the error, which is really useful if something sometimes doesn't work. It doesn't stop the calculations from running, it just captures the error, and then just moves on to the next one. And then at the end, you just have a list where sometimes an error is taught and you can diagnose it later, which is really helpful on those maps that takes hours that you run overnight. So if one of them didn't work for a weird reason, maybe the seed was wrong, you did the convergence, creating a safely means you still get the remaining results back. And then slowly, just makes it so the function can only be run so often. So I use it a lot for like, I do some scraping. This is actually a direct copy paste for a script I run. So I created this long function called straight URL that takes a URL and does stuff. I have slowly applied to it, and it makes sure that the function can only be run every 1 or 5 seconds, something like that. So, which actually is an issue because the scraping takes longer. But it makes sure that I possibly can't send it a request faster than slowly allows. And just safely, as I said before, we'll make sure that any errors are being taught and you can then handle them after, if they happen. So there's many more things in Purrr, but these are like, you want to see the highlights. There's a couple of other, so if you like Purrr, use it, and you want to see like other things you can do. I realized future directions is not a great name. Also, I did this wrong. This should be, and I fixed this. Alright, so I said future directions. It's not, but it's already here. So we have, so if you know how to use the map functions, you put future underscore before the map, then use the plan function from the future package which is loaded, and you say oh, I want to run this in parallel in a multi-session thing with 2 vectors, and then the map is being done in parallel. So you don't have to set anything up, it just knows it for you. Yes?
Do you still have to set the number of workers manually?
I think it defaults to using all of them, which is a bad idea. But yeah, if at all possible, set it manually. Because you can crash some stuff if you let it use everything. And of course, interested, the future package is a way of specifying things to run in parallel. You can specify many different ways of running things in parallel. You can set it to run on a cluster. You can set it to just spin up R processes in the background to do things in a message path. It's things I don't like working with. So, but other people will do it for me. And yeah, so if you have something that runs for a while but doesn't take up a lot of memory, you can just run in parallel and then beat that almost n time increase. And another last little tidbit of like a related package is the slider package. So it behaves in many ways like Purrr. But what it does different is it works with sliding intervals. So sometimes you want to do things in a sliding fashion. And slider way to do this. So first one, we have the numbers 1 through 5, and it will tell you the mean of the current value and the last 2 values. So this is the way of creating a sliding mean. But you can put whatever function you want in there, and you can specify how the intervals should work. So it has a very like Purrr feel to it, but it does different things. And it's the same. It doesn't give you it doesn't know any neat tricks about calculating things in a sliding fashion. There are some tricks depending on what you're trying to do, but it just does the subsetting for you and calculates the function. But you don't have to actually manually track the indices. It handles everything for you. And that's everything I have.